Now let's look at how we can solve limits. So there are a huge number of ways how we can solve limits. Firstly, your job is to identify as to which type would be the best for you to solve limits in that question. So let's look at the first one. First one is direct substitution. Here what happens is there is not any type of indeterminate form that is forming. Simply whatever value x is tending to, you can simply substitute that in our function f of x and you can get the answer. For example, let's say if you have limit x tending to 3 and you have function here as x minus 2. So what would be the answer of this? You can simply substitute 3 in place of x and you can get 3 minus 2, which would be 1. This would be your answer. Factorization. Sometimes what happens is whenever you put the value of x in the function, it is going to come in the format as 0 by 0, like it has been shown here. So what is your main job here? Your job is to create factors of either the numerator or the denominator and then cancel out whatever factors you found out and then direct substitute the values. For example, one of the examples could be, let's say you have x square minus 9 upon x minus 3. Here we have limit x tending to 3. If I put 3 in this entire function, what is it going to become? It is a 0 by 0 indeterminate form. However, if I try to factorize this function, what can it become? It can become x plus 3, x minus 3 upon x minus 3. Here this and this would get cancelled and we would be left with x plus 3. If I put limit x is equals to 3 in this equation, we would get 6 as our answer. So this is how a factorization question basically works. Next is rationalization. Multiply the numerator and denominator by conjugate in cases involving square roots to simplify the expression. I hope you all know. Let's say if you have root under x plus 1. Now if you want to find out what its conjugate going to be, its conjugate simply is going to be multiplying x minus 1. So substituting the sign in any one of the terms makes it a conjugate of the other number. So if you multiply those two numbers, it would simply rationalize and then give you your answer. Again, whenever you put the value, direct substitute the value of x, which is it tending to, in the function, it is going to form an indeterminate form. That time you use rationalization as well. Now trigonometric limits, these are certain limits that you must remember. Whenever x is tending to 0, sin x by x, its answer is always 1. Now the proof of this we will learn when we study Maclaurin series. There we will look into the proof in detail about all these things, but it is recommended that you remember all these functions because during solving the questions, these type of functions come in handy. So after that, we have logarithmic and exponential. Again, these are certain standard values that you must remember. 1 plus x to the power 1 by x when x is tending to 0. If you look at this carefully, this is 1 to the power infinity form. This value comes out to be e always. And here ln x by x, where x tends to infinity, this value is 0. Now there is another format of calculating our limits, which is LH rule. We call it L'Hopital's rule, or sometimes people call it as L'Hospital rule as well. So this can be used only when you have determinant forms in this format, 0 by 0 or infinity by infinity. So you must remember this. The indeterminate form in which you can use L'Hospital rule is 0 by 0 or infinity by infinity. And what happens here is, let's say if you have limit x tending to a f of x by gx, you simply differentiate the numerator separately and the denominator separately, and then you find out your answer. So let's say let's take the previous question that we had done. X tends to 3, limit x tends to 3, and we had x square minus 9 upon x minus 3 here. Now you can see that this is a 0 by 0 form, right? Now what if I was to apply LH rule here? If I apply LH rule, what would this become? Limit x tends to 3, the differentiation of the numerator separately, which makes it 2x, and the denominator separately. So this makes it 1. So from here, after substituting 3, we would get 6 as our answer. So I hope you understood how L'Hopital rules is generally used. Expansion method. There are certain logarithmic function, exponential and trigonometric functions which can be expanded in using the Taylor series or the Maclaurin series. Again, Maclaurin series is an important topic. We will be looking at that. And based on that, you can simply expand any function in terms of x. After expanding that, you can solve your limit. So it becomes easier that time. For example, you can see here, limit x tending to 0, ln 1 plus x by x. Now ln 1 plus x can be written as x minus x square by 2 plus x cube by 3 minus, and this goes up till infinity. So simply I can substitute ln 1 plus x with this value. So what would it become? Limit x tending to 0, ln 1 plus x, it can be written as x minus x square by 2 plus x cube by 3 minus, and this goes on upon, I had an x. So what can I do is I can take x common from the above equation. So if I take x common, what would happen? X tending to 0. I have taken x common. What am I left with? 1 minus x by 2 plus x square by 3 minus, and this goes on by x. X and x would get cancelled out. And if I substitute the value of x as 0 now, what would I be left with? All these terms which have x in it would simply turn out to be 0, and I would be left with only a 1. So 1 would become my answer. So this is how you use the expansion method. This is generally done in trigonometric functions, logarithmic and exponential functions. So remember this thing. Now, whenever you have an indeterminate form, which is 1 to the power infinity, what we do is we convert it into an exponential. Now this entire thing can be written as limit x tending to a e to the power gx ln f of x. So let's say if I was to replace this entire thing, I hope you all remember we had studied this in functions, ln f of x. If we have, let's say, a k here, it can be written as ln f of x to the power k. These two are basically similar. So that is exactly what has been done here. The k, which is my gx here, gx has been brought to the side, and I've taken an exponent of all this entire term. Indeterminate form, infinity by infinity, again we use the L'Hopital's rule to solve our questions. So now let's look at all these methods one by one in detail. So first one which we studied was direct substitution. So this is a question of direct substitution. Always you start the question of limit by direct substituting the value. So sometimes in questions you can directly get a finite value which is not 0 or in any terms of indeterminate form. That time you can say that this was a direct substitution question and we directly got the answer. For example, here this is a direct substitution question. Simply I can replace x with 3, and what would I get? This would become 3 square plus 2 times 3 minus 5, and this comes out to be 9 plus 6 makes it 15 minus 5 10. This is my answer. Direct substitution works this way. This is our factorization. We saw this earlier as well. We saw an example which was in this format only. What we first do is we first put the value of 2 in the equation. What do we get? 0 by 0. That means an indeterminate form. So if it is 0 by 0, either I can use L'Hopital rule or I can simply factorize it. I can see that there are factors that are forming. So I can write this down as limit x tending to 2, x minus 2 into x plus 2 upon x minus 2. This and this gets cancelled. Upon replacing 2, we get 4 as our answer. Now this is rationalization question. What do we see here? Let's say if I simply substitute the value of x as 0, what am I going to be left with? X would become 0, this root 1 would be left with 1, and we get 0 by 0, another indeterminate form. Again, you can use L'Hopital rule, but you can see that there is a root of x. So differentiating this term would become a little difficult for us to solve, right? So what we do is we try to rationalize this. So how can this entire term be rationalized? This can be rationalized by multiplying it with its conjugate multiple. So x plus 1 is here, minus 1 we already have upon x. So what I do is I multiply the numerator with root under x plus 1 plus 1 upon root under x plus 1 plus 1. Now I can simply rationalize this. So this would become limit x tending to 0. This square root would open out to become x plus 1, and here we would have minus 1 upon this would become x root under x plus 1 plus x. Here minus 1 and plus 1 gets cancelled. From below we can take x to be common, so x and x would also get cancelled out. So what are we left with? X tending to 0, 1 by this would become root under x plus 1 plus 1. Now if we substitute x as 0, what do we get our answer to be? 2. So this becomes our answer. So this is how rationalization question is done. You must remember, generally this is done when you have, let's say, square roots or heavy, let's say, power roots used. That time you use rationalization to simplify your equation either in the numerator or denominator, and then use our direct substitution in the end to get the answer.